Morning, everybody. Hope you guys are doing well. Back with my coffee, morning coffee. But today I'm hanging out with somebody. And yes, virtually we're hanging out. And he's got a couple of puns for you. So maybe that gave it away. But enjoy the expert punning from Mr. Richter.
Why, yes, it is a beautiful morning, wouldn't you say? I'm sorry that I was a little latte to our meeting, and I don't mean to milk you quite like this. But you know what they say, you really gotta espresso yourself correctly in the morning.
All right, I got one. Want to hear it?
Oh, yes, please do tell me.
All right. I know you make good coffee, but have you met my brother Pete?
That was a pun?
Yes? Question mark?
Okay, bye.
Well, I guess he didn't like my joke.
Alright, so today we're looking at the homework for section 13-1. So if you haven't already attempted or completed the homework for 13-1, pause this video, go in and finish the homework, and then come back to this video because I'm just going to be going over all of the solutions to the homework. Okay, so question 1 says when you're opening a rotating combination lock, is the order important or not important? So is this a permutation or combination lock? And I went over this in the lecture. When you're looking at a combination lock, the order is important. So this is actually a permutation. Question number 2. Jamie purchased 3 blouses, 3 jackets, and 2 skirts. How many different outfits using a blouse, a jacket, and a skirt are possible? So this is using the fundamental accounting principle. So we're just going to multiply all the items together. So 3 times 3 times 2, and that gives you 9 times 2 is 18 ways. Number 3. An internet code consists of 1 digit followed by 1 letter. The number 0 and O, the letter O, are excluded. So how many codes are possible? So this is where you have your 2 options. Now since we're not using the number 0, that gives you 1 through 9, so there are 9 options there. We're using every letter except O, so there are 25 letters remaining. So using the fundamental accounting principle, I multiply both together, and that will give me 225 different ways. Number 4. Nate is on a 7-day vacation. He plans to spend 1 day jet skiing and 1 day golfing. How many ways can Nate schedule the 2 activities? So for number 4, we have to ask ourselves, for this question, do we have a permutation or combination? Which one am I looking at? Well, since he is on a 7-day vacation and he wants to do 2 activities, our number of items, so n is equal to 7, r is equal to 2. That's how many items I'm selecting. But is it permutation or a combination? Well, since Nate can't do both activities at once, the order does matter. So this would be a permutation. So we would have 7p2, which gives me 7 factorial over 7 minus 2 factorial. That gives me 7 factorial over 5 factorial, so 7 times 6 times 5 factorial over 5 factorial. Those cancel, and I'm left with 42 ways. So that is the answer to number 4. Number 5. how many ways can you listen to 3 songs from a CD that has 12 selections? So number 5, we're looking at either a permutation or a combination. Now the question you have to ask yourself is, can you listen to 2 songs at once? Well, no, you can't listen to 2 songs at once from the CD, so this would be a permutation because the order does matter. The order is important, so there's an arrangement occurring. So what's your total number? Well, I have 12 selections. I'm picking 3 songs, so I'm going to have 12 P3. That's going to be equal to 12 factorial over 12 minus 3 factorial, 12 factorial over 9 factorial, and that gives me 12 times 11 times 10 times 9 factorial over 9 factorial. Those cancel each other out, and left with 12 times 11 times 10, which gives you, what does that give you? 1320. 1,320 ways. Now again, notice that this is the fundamental counting principle. So if you use the fundamental counting principle on that one, that's totally okay. Number 6. Members from 6 different school organizations decorated floats for the homecoming parade. How many different ways can first, second, and third prizes be awarded? Now, for this one, again, what's in? Well, we have 6 different school organizations. Now, how many items am I selecting? Well, I'm selecting 3, first, second, and third. Now, is this an arrangement or a grouping? Well, first, second, and third, that's in specific order, so this would be an arrangement. We have a permutation. So number 6, we would have 6p3, which gives you 6 factorial over 6 minus 3 factorial, 6 times 5 times 4 times 3 factorial over 3 factorial, so 6 times 5 times 4. Again, notice the fundamental counting principle on this one. And that will give you 120 ways. So that's answer number 6. I'm not going to go through all this for everyone. I think you guys get the idea. Number 7, a teacher wants to send, just a second. A teacher wants to send 4 students to the library each day. There are 21 students in the class. How many ways can he choose 4 students to go to the library on the first day? Now for this question, let's identify N and R. So what is N? What's the total number of items? In this case, students. You have 21 students. Now how many are you picking? You're picking 4. Now is this an ordering or a grouping? Or an arrangement or a grouping? Well, they're just picking 4 students. They're choosing 4 students to go on the first day. So they're not saying John go first, Emily go second, Tyler go third. No, we're not going in a specific order. You're just taking a group of students, a group of 4 from the 21. So this would be a combination. So our combination is 21C4, which, remember, the formula for the combination is 21 factorial divided by 4 factorial, and then 21 minus 4 factorial. So that's going to give you, I'll show you guys how to do this one. So 21 times 20 times 19 times 18 times 17 factorial over 21 minus 4 is equal to 17, so you're left with 17 factorial. And you have 4 times 3 times 2 times 1. Those cancel each other out. And then when you do 21 times 20 times 19 times 18 over 24, 4 times 3 times 2 times 1, and you can multiply these together, then divide by 24, and that will give you 5,985. All right, number 8. So with number 8, let's see, Gregory has a coupon for $1 off of the purchases of 3 boxes of Munchie brand cereal. The store has 5 different varieties of Munchie brand cereal. How many ways can Gregory choose 3 boxes of cereal so that each box is a different variety? So what's the total number of items that I have? Well, the total number is 5. How many items am I taking? I'm taking 3. Now is arrangement or a grouping? Well, he has 5 different, 3, 4, 5 different boxes of cereal. You're just taking 3 at a time. You're just reaching up and grabbing 3 items off the shelf, you could think. So this would be a grouping, combination. So you have 5C3. That's going to give you 5 factorial over 3 factorial times 5 minus 3 factorial. That will give you 5 times 4 times 3 factorial over 3 factorial times 2 factorial, which is 2 times 1. That will give you the factorials cancel here. 5 times 4 over 2. 4 divided by 2 is 2, so you're left with 5 times 2, which is 10. So 10 ways for question 8. Number 9. A hiker can take 4 trails to the lake and then 3 trails from the lake to the cabins. How many routes are there from the lake to the cabins? Now this question might throw a few people off because of the way it's worded, especially this end part. And the reason for that is because you have the hiker going to the lake into the cabin. So it says the hiker can take 4 trails to the lake. 1, 2, 3, 4. Then 3 trails from the lake to the cabin. 1, 2, 3. Now where this might throw people off is the question saying how many routes are there from the lake to the cabin? Well, some people might say just 3 routes. Now this is not what the solution has in the book, and this is not what the solution that I'm going to give, even though the way that this is worded, I completely understand if you were to put that. It's not a great question, but what this question is actually asking for is using the fundamental accounting principle to find really the number of routes from the start of the hiker's journey to the cabin. So we're going to use the fundamental accounting principle. We have 4 routes here, 3 routes here, multiply them together to get 12 different routes. And that's the question, the answer to the question in the book. All right, number 10. Number 10, the cheerleading squad is making posters. They have 3 different posters, colors of poster boards, and 4 different colors of markers. How many different posters can be made using 1 poster board and 1 marker? For this one, we're saying how many different ways, we're counting the number of different ways given 3 colors for posters and 4 colors for markers. This is just using the fundamental accounting principle. It's the easiest way to do it. You just multiply 4 times 3, or 3 times 4, it doesn't matter. And you get 12 different combinations there. 12 different posters. And that's number 10. Number 11, how many ways can you choose a manager and assistant from a 9-person task force. Now with this one, again, we're going to be looking at, is it permutation or combination? What's my total number of items? How many items am I selecting? Well, the total number of items is 9 because you have 9 people. How many items are you selecting? Well, you need a manager and assistant, so you need 2. Now, you're not just taking 2 people randomly to fill up 2 random positions, so you're not taking a group of people. Once you fill the manager position, they're off the list, and then you can fill the assistants. So this would be a permutation. So the order matters here. So you'd have 9p2, which gives you 9 factorial over 9 minus 2 factorial, which then gives you 72. So you do this 72 different ways. Number 12. How many identification codes are possible by using 3 letters if no letter may be repeated? This one is, it would be easier to do this one just by using the fundamental accounting principle, because you have 3 numbers to input into the code. Not numbers, we have letters. Letters. So we have 3 different letters. Our first option is 26, all the letters of the alphabet, but we cannot repeat. So once I use a letter, let's say I use A, I can't use A again, so I have 25 options here. Let's say I use B, can't use A or B, so I have 24 options here. So I multiply them all together, 26 times 25 times 24, and that gives you 15,600. Now you could have used a permutation with this. You could have said you have 26 items, permutation because the order matters, and you're selecting 3 items. So that would give you the same solution. So hopefully you guys see that there are different ways you can think through these. Alright, number 13, you have 5 planes ready to depart. Runway A and runway D are available. How many ways can 2 planes be assigned to runways without using the same runway? So with this one, you have your 2 runways. There's runway A and runway D. And you have your 5 planes. Imagine that's a plane. 4 and 5. So there's your 5 planes. Now, for my first runway, let's look at A. Now you can't go at the same time, obviously. So you have 5 options here. And then once you select a plane, let's say I select this one, goes first. Well, then how many options do you have for the second one? You have 4. So if that's your 2 options there, and this is using the fundamental accounting principle, so that would give you a total of 20 different ways. So this is kind of like the Cinderella example, because once you assign a plane, it can't be reused. Another way you could do this is using a permutation. You could use 5, because you have 5 items, and I'm selecting 2. So you could use 5p2 to get 20 as well. Both ways work fine. Number 14. How many choices of 3 hamburger toppings are possible? And you have these toppings. So you have a total of 6 toppings. Would this be a permutation or a combination? Well, since you have the order doesn't matter how you put it onto your hamburger, you're just looking for a group of 3 toppings, this would be a combination. Number of total items is 6. Items you're selecting is 3, so you get 6c3, which gives you 6 factorial over 3 factorial times 6 minus 3 factorial. Now that is going to give you 6 factorial times 3 factorial times 3 factorial, and that will give you, you can do this one, 6 times 5 times 4 times 3 factorial over 3 factorial times 3 times 2 times 1. So those factorials cancel. 3 times 2 is 6. Those cancel. So you're left with 5 times 4, which is 20. Number 15. In the United Kingdom's National Lottery, you must correctly select a group of 6 numbers from 49. Now the question is, suppose that the contests were changed to selecting 7 numbers instead of 6. How many more ways would there be to select the numbers? So we're looking for what's the increase in ways to select the numbers if you go from selecting 6 numbers to 7. So how many more ways are there? So to do this, just think that you have the new way, we'll say that's A, the old way is B. I'm looking for the increase from both. So I'm going to do the new way, which is option A using 7 letters, and then whatever number I get here, I'm going to take away selecting 6 numbers. The way to select 6 numbers to get my total increase there. So let's count the number of ways to select each. Now using the old way, we're using 6 numbers from 49. Would that be a permutation or a combination? Now the order doesn't matter here because you're just selecting a grouping of 6 numbers from 49. So for this one, you would have 49C6. If you change the number to 7, you have 49C7. So what you're going to do to solve this, I'm going to take the new way, which is with the 7 numbers. So we're going to do 49C7 minus 49C6, and that's going to give me the total increase of numbers, of ways to select the numbers. So 49C7, that's going to give you 859000584. We're going to subtract 49C6, that gives you 13983,816. When I subtract those two numbers, the solution is 71,916,768 ways. So if you add one number, there is 71,916,768 more ways to select the numbers. So you see, just by adding one number to the lottery, how many more ways you can select the number. So it really increases the total number of ways. 16 through 23, this is just evaluating some more practice of just evaluating your factorials and permutations, combinations. So I'll quickly go through these. So number 16, 6p6, you're going to have 6 factorial over 6 minus 6 factorial. 6 factorial over, well, 6 minus 6 factorial, 0 factorial. Remember, 0 factorial is always going to be 1. So you're just left with 6 factorial, which gives you 720. Number 17, you have 5c5, that gives you 5 factorial over 5 factorial over 5 minus 5 factorial. Well, these two factorials cancel each other out, so you have 1 on top, and then 1 times, well, 5 minus 5 factorial is 0. So you have 0 factorial, which is, again, 1. So you have 1 times 1 times 1, which is just 1. Number 18. Nine P1, that gives you 9 factorial over 9 minus 1 factorial, which is 9 times 8 times factorial over 8 factorial. Those cancel, and you're left with 9. Number 19, 6C1, that gives you 6 factorial over 1 factorial times 6 minus 1 factorial. 6 times 5 factorial over 1 factorial is just 1. You have 5 factorial, those cancel, and you're left with 6. Number 20, 2 factorial, which is 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Those cancel, are left with a 1 on top, and then 6 times 5 times 4 times 3, that gives you 360. Number 21, we have 4 factorial times 3 factorial over 2 factorial. That gives you 4 times 3 times 2 factorial, and 3 times 2 times 1 over 2 factorial. Those cancel, so you're left with 4 times 3 times 3 times 2 times 1, which gives you a total of 72. Number 22, 9 factorial over 7 factorial, 9 times 8 times 7 factorial over 7 factorial. Those cancel. 9 times 8 is 72. Number 23, you have 8 factorial minus 5 factorial over 8 minus 5 factorial. Now this one is a good question to know because the top here, you have to solve that individually. You can't combine like you would here. So what I'm saying is that you can't do 8 minus 5 factorial and then solve that factorial because these are individual factorials here. So you actually have to say, well, what's 8 factorial? What does that equal? Well, 8 factorial is equal to 40,320. And then you have to say, well, what's 5 factorial? So minus 5 factorial is 120. Then we're going to divide by 8 minus 5 is 3 factorial, which is 3 times 2 times 1 is 6. So then you will get, well, 40,320 minus 120. That gives you 40,200 over 6, which gives you 6,700. And that's the answer to number 23. Alright, so that's the homework assignments. Hopefully that was helpful, kind of going through each of these homework questions so you guys get a better understanding of how the combinations, permutations, fundamental accounting principle, and factorials work. If you have any questions, feel free to email me and we can go over any of this. Alright, have a good day.